Hi, and welcome to today's SFP webinar on integrated system testing, what a fire protection engineer needs to know. This is Louis Garazzi, SFP's Manager of Professional Development, and I will be moderating today's webinar. Before we get started, I'm going to go over some information in regards to webinar logistics. First, all participants will receive a certificate of attendance for one PDH. To receive a certificate, you must stay online for the entire webinar. Certificates will be sent out via email in about 1 week. Also, we do not provide copies of the speaker's PowerPoint presentation. However, we will be posting a video or this presentation on the SFP's YouTube channel and website next week. This webinar will also utilize the polling feature to take a survey of attendee experience. When prompted, please look to the webinar dashboard to respond to the poll. Polling will be open for approximately 20 seconds. Once the polling closes, we will share the results of that poll. Additionally, you can ask our speakers questions by writing it in the webinar dashboard. You may ask a question at any time. However, we will not be taking any questions until the end of the webinar. Today's speakers are Shawn Mahoney and Jacqueline Wilmot. Shawn Mahoney is an associate engineer in the Technical Services Division at the National Fire Protection Association. He's a registered professional engineer that holds a BS in Mechanical Engineering and an MS in Fire Protection Engineering from Worcester Polytech Institute. Prior to joining NFPA, he held a variety of positions in fire protection engineering, including fire protection consulting and fire protection product design. Shawn contributes to an assortment of projects, including assignments distributed among the building, life safety and fire protection, public fire protection, electrical and industrial and chemical engineering departments at NFPA. Jacqueline Wilmot is a fire protection engineer at the National Fire Protection Association. She holds a bachelor's degree in chemistry from Chatham University and a master's degree in fire protection engineering from Worcester Polytech Institute. Before joining NFPA in 2014, Jacqueline worked as a fire protection engineer for 3 years at Engineering Planning and Management Incorporated, where she provided fire protection and regulatory consulting services to the nuclear power industry. At NFPA, Jacqueline is a staff liaison for 7 different technical committees in fire protection, building, and life safety divisions. So, with that being said, welcome, Shawn and Jacqueline.
Thank you, Louis, for the introductions and for having us today. Also, thank you to all of you who have made the time to log in and listen to today's webinar. So just to get a feel for how many of you have heard of NFPA4, we have a couple poll questions coming up. The first one is how many of you have actually heard of NFPA4, the standard for integrated system testing of fire protection and life safety systems? Take a couple seconds here to complete the poll. Louis, we haven't been able to see the results quite yet.
Okay. The poll results have closed. It looks like we are seeing 66% of the attendees have heard of NFPA4, with 34% who are not aware of NFPA4.
Okay, so that's actually more than what Shawn and I were anticipating. That's a good thing. As we move forward, as time moves on and NFPA4 has been on the streets longer, we are finding more and more people are familiar with NFPA4, which is great. The next poll question we have for all of you is how many people attending this webinar today have conducted integrated system testing or have been involved on an integrated system testing team in some way?
All right, Jacqueline, and we've closed that poll, and we're looking like we have 42% who have conducted integrated system testing and 58% who have not.
Okay, thank you very much, Louis. So 42% of you have been involved in some way, shape, or form with integrated system testing, and it'll be interesting to hear the questions that we have at the end of this webinar, just based on people's experiences thus far using NFPA4 or being involved in integrated system testing. So thank you for participating in the polls. Before we get started, I just wanted to make you all aware that Shawn, Mahoney, and I will be splitting up some of these slides. So if you hear a shuffle of the headset in between, that's what that is. We'll try to be as smooth as possible. And now we'll get started. So Shawn and I have been doing this presentation for quite some time. One of the things that we noticed is that depending on the audience, people tend to be very curious on the evolution on how NFPA4 evolved, where it came from. So to give you a little bit of background, in 2007, the National Institute of Building Sciences, also known as NIBS, requested NFPA to establish a new technical committee for commissioning of fire protection and life safety systems. Now, as many of us are aware, commissioning takes place for a variety of systems in our buildings today, whether it be HVAC, plumbing, or LEED buildings, and fire protection was just one piece of the puzzle that was missing. So in 2007, the NFPA Standards Council sought input from various existing technical committees as well as the general public, and in late 2007, a technical committee on commissioning fire protection and life safety systems was established. This kickoff meeting took place later in 2007, and when the technical committee met, they quickly realized the scope of the committee needed to be expanded beyond commissioning to address testing of integrated fire protection and life safety systems. The technical committee name was changed to the Technical Committee on Commissioning of Fire Protection and Life Safety Systems, with the responsibility of developing a document to address both of these items. So between 2008 and 2011, a lot of technical committee meetings took place. If there's any technical committee members on the phone, they're very aware of how many meetings occurred during that time period. During those 5 years, the committee had flipped cycle. There was a lot going on, but the good news is in 2012, the first edition of NFPA 3, which at the time was a recommended practice on commissioning of fire protection and life safety systems, was published. And what's important to know is that within NFPA 3, Chapter 7 within NFPA 3 was dedicated for integrated system testing. Well, in 2015, which was the second edition of NFPA 3, the committee decided they really needed to break apart the subject of integrated system testing and really mandate that language so that integrated system testing becomes its own standard. So here we are now, and we're currently working on the third edition of NFPA 4, but a lot of people do question, I heard of NFPA 3 and I heard NFPA 4 came from NFPA 3, and it did. It originally was a recommended practice, just a chapter in a recommended practice, and after time and much consideration, the committee believed that the subject of integrated system testing needed to be mandated and needed to be separated out. They weren't sure at the time if commissioning really needed to be a standard. However, now in 2018, NFPA 3 is a standard, so we do have a standard on commissioning, but just to kind of give you a little bit of backstory as to how NFPA 4 evolved into what it is today. So in this next slide, we actually have a picture from the NFPA 3 and 4 handbook, and I think that this image really highlights why integrated system testing is needed. So for the top photo, we have, it's a picture of the New York City skyline back in 1902, and the bottom photo is back in 2014. So I think that this really highlights the advancement in technology that we've had, the systems that we have in our buildings, because in the late 1800s, early 1900s, when sprinkler systems were first utilized, they were truly independent systems, meaning they weren't communicating with other systems because, quite frankly, we didn't have too many other systems that they could communicate with. However, there's obviously been a significant advancement in technology and a platform for multiple fire protection and life safety systems to communicate with one another. This is important because even today, we don't rely on one specific system to detect, notify, suppress. We rely on all these systems to allow us to safely egress a building in the event of an emergency. NFPA 4 mandates the systems which are intended to function together are actually tested to ensure the interaction, operation, and coordination of multiple integrated systems are functioning properly. Now, keep in mind, although NFPA 4 was new in 2015 as a standard, integrated system testing is certainly not a new concept. In the 1930s, the highly protected risk insurance industry needed to ensure that fire sprinkler activations were acted upon in a timely fashion. So shortly thereafter, NFPA 71, the standard on central station service, required the inspection and testing of sprinkler water flow valves, which were required to be monitored per the listed central station. And now the language that was put in NFPA 71 is now included as part of NFPA 72, which of course is our signaling code. So now that we're here today, Shawn is going to talk about some of the documentation that a lot of us are familiar with in today's buildings. But I want to, again, go back to this picture because in the early 1900s, we might not have had the systems available for them to interact and talk with one another. But again, we certainly are not relying on one individual system to get us out of a building safely. So we can see the advancement in technology and obviously the amount of systems that we have today and how this gap began to form and now how NFPA 4 is addressing it. So Shawn, you can go to the next slide and start talking about the documentation that we currently see in buildings today.
All right, thank you, Jacqueline. So here's a list of some examples of the types of documentation that exist in buildings today. So you've got the engineers, contractors, and architects providing affidavits to certify that all the work's been performed according to the plan, design, construction, and/or the installation standards. Then you've got inspectional services departments and fire departments are providing their sign-offs for any of the inspections that they performed on the building during the construction project. All the contractors for each different system, that includes the fire alarm, elevator, electrical, sprinkler, HVAC, security, and BMS systems, they all provide documentation for their own systems. And this documentation certifies that all of the systems have been installed per design. Most, if not all, of the documentation that I've talked about is centered around the specific systems and components within the building. There's no documentation for the building that's showing that all of these systems and components will work together as intended during an event. So this is where the testing and documentation per NFPA 4 starts to come into play. So let's talk a little bit about some codes and standards and the scopes of these standards. Here's an example of some of the systems that can be within a building. We've got elevators and fire doors, which are covered in NFPA 80 and ASME A17.1. You've got other monitored systems such as standpipes, which are covered by NFPA 14, kitchen suppression systems, which are covered by NFPA 96. You've got smoke control systems and HVAC control systems, which are covered in some standards, including NFPA 92 and 90A. Again, we've got some fire doors and smoke doors and dampers, which are covered in NFPA 80. Buildings can contain emergency communication systems. These systems are covered in NFPA 1221. And then we've got the fire alarm and supervising station, which are covered by NFPA 72. And then we've got the sprinkler system in the building, which is covered by NFPA 13. And all these documents have the scope to provide the specific design, installation, and acceptance testing requirements for each individual system. So where you have systems like a fire alarm and a kitchen hood suppression system that are interconnected via a relay, you have the kitchen hood. When it activates, the relay will close, and then it sends a signal to the fire alarm system, which then responds accordingly. So in that case, the scope of NFPA 72 is going to cover the design, installation, inspection, and maintenance of the fire alarm system, while the scope of NFPA 96 is going to cover the design, installation, inspection, and maintenance of the kitchen hood suppression system. But neither of these standards are providing requirements on how these two systems must be integrated. So a test of the fire alarm might make sure that given a signal from the relay, the fire alarm produces the correct response. And then a test from the kitchen hood might make sure that a signal is sent from the kitchen hood to the relay. But then there's questions about, well, what about testing to make sure that relay works? And if the connections inside the relays are working, make sure that the response from the fire alarm is as intended. What about if the communications between that kitchen suppression hood and the fire alarm are maybe not through a relay? Maybe it's through something like a data connection or a wireless interface. How do we know that all these communications are working correctly? And all these questions get answered by NFPA 4. So the scope of NFPA 4 covers all the interactions interconnections and integrations between these systems. The document outlines how to test all the interconnections and integrations to confirm that the systems are properly interconnected or integrated. So when all the testing is completed per NFPA, NFPA 4 is then going to provide requirements for the type of documentation that you need. So systems can be interconnected using many different types of connections. You can have either a switch connection or a data connection. And what a switch connection does is it allows the transfer of 1 byte of binary data, which is either an on or an off signal. And you have a data connection, which can provide the transfer of more than 1 byte of information. And then data connections will actually allow the flow of information back and forth between 2 systems. And one common misconception that we get when talking to people about integrated systems is that integrated systems contain only physical connections, but in reality, integrated systems do not need to be physically interconnected. So, for example, if you have a pressurized stairwell, that's going to rely on active systems such as the fan, the ductwork, and the louvers. But the system's also going to depend on a passive system that includes the shaft wall construction, any of the doors and dampers that are used to close off the stairwell, and that's used to maintain the integrity of the space. So if you had a failure of either the active system, being the fans and the ductwork and louvers, or the passive system, saying you had a hole or something in the shaft wall, you're going to lose pressurization within that system. So those are considered all integrated systems. And integrated systems become more and more common in the built environment. So advances in technology coupled with Internet of Things are rapidly changing the topography of the information communication. So as Jacqueline was talking about, fire protection is not immune from the consolidation of information. So you're going to soon see devices will be connected using an internet protocol, and control will be centralized within the building. Integrated systems will increase, and the need for integrated system testing will be more important than it is even today.
Okay, so now we're going to just go over the main points or highlight some of the main points in NFPA 4. Shawn and I do have an 8-hour program on this, so it is hard to fit a lot of that information, into a 1-hour webinar. But we want to touch on some of the key takeaways here from NFPA 4. So the first and foremost is terminology. So earlier I was talking about NFPA 3 and commissioning. Well, the term commissioning has a lot of different meanings to a lot of different people. So quickly, I would like to just clarify some of the confusion that does arise between NFPA 3 and NFPA 4. So when we talk about commissioning, it's important to compare that to acceptance testing. So when we're talking about acceptance testing, we're really talking about when we're confirming operation of individual systems to perform their intended function. So obviously, when, as many of us are familiar with, acceptance testing happens, when the building's constructed, or when you're acceptance testing a new system in your building. And the definition of commissioning in NFPA 3 is different than acceptance testing. And I often hear people say, oh, I commissioned that system. Well, they really mean they acceptance tested that system. Because commissioning in NFPA 3 is very different. So commissioning in NFPA 3 is really a process, and it's a systematic process that provides documented confirmation that building systems function according to the intended design criteria set forth in the project documents and satisfy the owner's operational needs, including compliance with applicable laws, regulations, codes, and standards. So you might not agree with the definition of commissioning, but just know how it's used in NFPA 3 because we do use the terminology acceptance testing and commissioning and integrated system testing. So with that being said, the definition of integrated system testing is to confirm the operation, interaction, coordination of multiple individual systems to perform their intended function. So those are the definitions that we have in both standards for NFPA 3 and NFPA 4. What's scary with integrated system testing is that I would say a lot of people think this is already being done. The general public assume that when they walk into a building that the systems in that building have been tested, which could be true. Acceptance testing, a lot of the systems obviously have gone through that. But a lot of people, I don't think, are aware that we rely on the systems to communicate with one another. And that handshake it's never been mandated for that handshake to be tested. So that's really the purpose of NFPA 4. So for those of you who are familiar with NFPA 4, you've noticed that it's not a prescriptive standard. It's scalable. So when we walk through some of these points here, so when we talk about the integrated system testing team, well, that's going to be scalable depending on your project, the complexity of your systems, the complexity of your building. When we talk about running a test plan, there's 11 different items that we outline in NFPA 4 that need to be included in the test plan. It can be anywhere from just a simple list of the individual systems that are required for testing, to the test frequencies, drawings that are associated. Shawn is going to talk more about the documentation, but we do have something called an input-output matrix. And then so the test plan includes those 11 different items. But again, the integrated system testing team is scalable. When we move on to the next bullet here around the circle, develop test scenarios. Again, that's scalable as well. So it's not exactly an equation. Standard's not going to say if you have X, Y, and Z systems, this is the test you need to do. When we move on to identify the frequencies at which these systems need to be tested, you're not going to see something like this. This type of system needs to be tested every 5 years. It's really going to depend on a lot of different things that we'll get into in the next couple slides here. And again, Shawn will go through some of the documentation that we require at the end. Okay, so I'm going to spend a few minutes here talking about the integrated system testing team. So obviously, the two pictures we have here on the left, we have Wawa, which for those of you who are not familiar, it's just a convenience store, gas station. They make hoagies. I'm from Pennsylvania, from the Philadelphia area. Living in Boston now, everyone has Dunkin' Donuts, but you get the idea. It's a convenience store, small. They probably have a fire alarm system and a sprinkler system, and that's it. The photograph on the right is Mandalay Bay. So for those of you who have been to the NFPA Conference and Expo, this is where we have our C&E every other year. And obviously in a facility like this, there are a lot more systems between the casinos, the ballrooms, the hotels, the restaurants. I mean, they have roller coasters. All these buildings are interconnected. So there's a lot going on. So when you're talking about the integrated system testing team, it might only be one person when you're at Wawa. It might just be the facility manager. And again, it could be Dunkin' Donuts, Starbucks, whatever your convenience store might be. Or if you're at something like Mandalay Bay or the World Trade Center, this could be a few hundred people. So who's involved? How do you know who to hire? Well, the owner of the facility is required to hire what we call an integrated testing agent to perform integrated system testing. So that could be one person or it could be an entity. And after the integrated testing agent, the only other people that are required to be a part of integrated system testing are the inspection, testing, and maintenance personnel for each system that you have in your building. And those people have they should be familiar with your site because they've visited for the inspection, testing, and maintenance that they've done for those systems. So the only person or entity that's really unique when it comes to integrated system testing is the integrated testing agent. So the integrated testing agent, their responsibility is to schedule, document, coordinate, and implement anything and everything to do with integrated system testing. So imagine this person essentially is the quarterback of the team. The owner is responsible for hiring the integrated testing agent, which is interesting because until 2015, we didn't have a standard for integrated system testing. So if you were to ask yourself, who do you think would make a good integrated testing agent? Well, you might open up NFPA 4 and see we do have qualifications that are listed there. But right now, I don't have any certification or licensure requirement for an integrated testing agent. So who would make a good ITA? Or that's our acronym for it, but an integrated testing agent. Well, when we look at some of the great integrated testing agents that we've been able to observe and we've witnessed and seen good results from, it's really people who are well informed on the systems installed in your facility and how they interact and communicate with one another. So they have to be very familiar with the systems installed. They need to be aware, knowledgeable, and understanding of the performance verification methods to validate that those systems are performing their intended function. So if you're at Mandalay Bay, again, that could be a couple hundred people. If you're at Wawa, it might only be one person. And it may not even require a test, because if you think about it, an acceptance test for a fire alarm system and an acceptance test for a sprinkler system, if that's all that the wall had, for example, those two acceptance tests is essentially an integrated system test because the systems are so limited that the acceptance test for each of those systems would really already be an integrated system test. And that would, I mean, that's a unique situation, but that does come up. Now, it's not just the size of the building, it's the complexity of the systems. So if you were to take the same size of the convenience store on the left and turn it into a bank, one with a drive-through, just think of your local bank near your home. And that bank probably has a security system, automatic closing doors. They probably have some means or methods of contacting a police station if there's an issue. So now we have a much bigger test plan going on because there's more systems, there's more interaction between the systems. So who's involved really depends on the size of the building, the complexity of the systems, and we're going to talk about other people who could get involved on the integrated system testing team. We'll talk about the authority having jurisdiction. The AHJ may be very familiar with NFPA 4, or he or she may not be. However, I will say I think it's very important that the AHJ get involved early because he or she might have experiences from their jurisdiction that they want to see in the integrated system test, and it's important to include them in earlier on rather than later, so that when you show them the test, they didn't ask, well, why didn't you do, this version, or why didn't you run that test? So I would say lesson learned from observing is to definitely get the AHJ involved early. So I know that's a very quick rundown of the integrated system testing team, but essentially it's the owner who hires the integrated testing agent, and then you have the inspection, maintenance, and testing personnel for the systems that you already have in your building. So the person that's really unique here is the integrated testing agent. Okay, when we look at the test scenarios, again, NFPA 4 being so scalable, we're not going to say if you have this type of system or this type of building, this is the test that you need to conduct, or this is the test scenario we're looking for. So what's important to note here is that NFPA 4, we require one or a combination of the presence of smoke, so that's our image on the left here, water flow from sprinkler, or loss of normal power to conduct an integrated system test. So the presence of smoke is just another scenario that could initiate smoke detectors, elevator recall, door closures, smoke control systems. The purpose of testing for a flow of water in the sprinkler system is to confirm the alarm devices are associated, that the alarm devices associated are functioning properly. And then obviously it's important to conduct tests with normal power and non-normal power to verify your life safety systems function with emergency power or e-power. So when you look at the one or a combination of these events, there are obviously buildings that are out there that may not fall within one of these scenarios that would really test the building. And you really want to have a test scenario with teeth because you really want to stress these systems. So I look at these three events, one or a combination of the three, as an 80-20 view, meaning a majority of the buildings that we have here in the world, if you were to have one of these following scenarios occur, you're going to start to see the domino effect of your systems communicating with one another, or you'll see that they're not communicating with one another. But really, that's why those three scenarios are set in place. So again, it's not a prescriptive standard that tells you which tests are required based on the type of occupancy or the systems in your building. It's really up to the integrated testing agent, the owner, and the authority having jurisdiction to develop the test scenario. So what if you had a building that was that could have explosive atmospheres? That's a situation where what type of detection systems in the facility would you want to check? So that's something that does come up from time to time. So again, you are going to have to think outside the box. It's just be aware of those three scenarios, or a combination is what NFPA 4 requires, but you may have to do additional tests for your specific building. And again, the purpose of an integrated system test is to verify that all the required building functions occur. Each building and system is different, so you're really going to have to know your building inside and out to really develop a test scenario or multiple test scenarios. And the other thing that's important to note is depending on the systems installed in your building or your facility and the circumstances the systems could be subject to will help determine what types of tests that you'd like to conduct. And as I mentioned on the previous slide, the AHJ really needs to get involved early, just because if you're dealing with an AHJ who had a terrible tragedy happen in your town, they might want to run a similar scenario to really make sure that that won't happen again and make sure that the systems in your building are functioning properly. So the goal here is you really want to identify what isn't working. So you don't want to write a test plan that you know is going to come out with flying colors. You really want to stress the systems. And it's kind of opening a can of worms, which is scary, but that's really the goal here. So, you know, again, I'll go back to the point that people think that when they assume that when they walk into a building, all the systems have been tested. And again, they might have been through acceptance testing, but not holistically. So that assumption alone is just very scary. So it's important to develop a test plan or a test scenario with teeth, and it's going to be different for each building. But NFPA 4 requires one or a combination of this slide to occur as one of the test scenarios. All right, when we're talking about frequencies, this really determined how we developed NFPA 4 as a standard. So when is integrated system testing required, at least in accordance with NFPA 4? So NFPA 4, basically we say integrated system testing needs to occur when it's called out in a commissioning plan. So again, that's how 3 and 4 are kind of related to one another. Or if it's in your building code or the owner's documents. Maybe the owner wants to go above and beyond and make sure that their systems are intact. Or maybe the insurance rep wants to ensure that the buildings and the systems are going to work inside the building. So you might have additional requirements from the insurance industry that might require this. So when we talk about testing frequencies in NFPA 4, we split it up into 3 different sections. So we have initial, which is really for a building that's being constructed, excuse me. Then we have existing, which is really, think of just an existing building, like anything like Grand Central Station or Union Station, those 2 train stations in New York and Washington, D.C. respectively, that were constructed many years ago, obviously, when NFPA 4 wasn't around, probably integrated systems weren't even around, but now they want to do integrated system testing. So that's when the existing section would come into play. And then lastly, we have periodic, which, you know, this is a big deal because how often should we do re-integrated system testing? This was a very big discussion amongst the committee. The thought of every 5 years was thrown around or every 3 years, but does that rule really make sense if you're an office building? What if you're a hospital? So obviously the systems really play an important role in how often they should be tested. And again, the testing frequencies that are identified in your test plan are really up to the integrated testing agent, the owner, and the AHJ. So what they decided when it comes to periodic is that it should really be trigger-based. So when something is added to your integrated systems or revised, that's when an integrated system test should be conducted. Now, I want to be clear that the intent of NFPA 4 doesn't apply to something like if you were to replace a manual pull station or a horn and strobe. The intent is not to conduct end-to-end integrated system testing on every single pull station in your building. The idea is that you would take one of those pull stations on that zone and test it with the rest of your integrated systems. That's known as what we define as a control group test. So again, when we talk about initial, I just want to go back and highlight these because this is a lot of information to pass along here. But when we talk about initial testing frequency, it's integrated system testing would occur during the construction phase and may coincide with the acceptance testing of individual systems. This initial test is comprehensive test based on the test plan prepared by the integrated testing agent and approved by the authority having jurisdiction. There was really no controversy on this particular subject of initial from the technical committee over mandating an integrated system test for all new buildings. After the acceptance testing of each individual system, the committee believed that that was the next step. When it comes to periodic, the concept of mandatory fixed integrated system testing was, again, this was a very controversial item that the technical committee discussed. And they really talked intensely about requiring integrated system testing every 5 years. However, when you threw out different buildings like the hospital or the office that I mentioned, it just kind of seemed irrational to put the cost for for that integrated system testing to the owner. And it just seemed inappropriate because those types, maybe an office building isn't required to do that every 5 years. So rather than prescribing a fixed period, a project-specific frequency is required to be developed and identified in your test plan in accordance with NFPA 4. The last thing that I want to talk about when it comes to testing frequencies is what you'll see in NFPA 4 is we have a provision that states if NFPA 4 is being adopted, so your jurisdiction has adopted NFPA 4, we say that within 5 years of NFPA 4 being adopted, a test plan is required to be developed. I want to be really clear here that the test plan has to be developed. That does not mean the test needs to be conducted within 5 years. The plan that you have to develop within 5 years can specify a frequency or interval that makes sense for your building. Again, that's going to be the integrated testing agent, the owner, and the authority having jurisdiction. So, you know, if your jurisdiction adopts this in 2020, you have until 2025 to develop a test plan. And within that test plan, depending on your building, you could say, we're going to do this every 10 years. It's just that a test plan needs to be developed within 5 years of NFPA 4 being adopted in your jurisdiction. So that is a very quick rundown of some of the main concepts in NFPA 4. But again, what's important to note is how scalable it is, because your integrated testing team, your scenarios, and your frequencies are all going to be different depending on your project. They're all going to be scalable. So NFPA 4 is a great outline that helps you think and articulate the different considerations that you need to have in your test plan and your frequencies, but it's going to be different for every building that's out there.
All right, so now I want to take a little bit of time and we're going to talk about some of the documentation that's required for integrated system testing per NFPA 4. But before I get into it, there's just one thing I want to talk about a bit on documentation. Is the one thing to think about is we're not just making documentation for the sake of making documentation, right? Documenting the results of these tests and the means and methods for executing them is pretty crucial to the building's future. So as Jacqueline discussed, buildings that undergo an initial integrated system test typically have an integrated system test plan for either a periodic test that comes up or a trigger-based integrated system test. So having the accurate and easily accessible test results from the initial integrated system test takes a lot of the guesswork out of any of the future testing. So being able to understand the common failure modes for the given building and having those test scenarios laid out is going to save both time and money for the owner and then and the facility management team. So that being said, NFPA 4 outlines required documentation in Chapter 7. This documentation is to be completed by the integrated testing agent and at the completion of testing. And the documentation is required to be submitted to the owner and then where requested, any other stakeholders. So that could be insurance representatives or the authority having jurisdiction. And the final test report must summarize the results of the testing. And the test report should include the test plan, an input-output matrix, sequence of operations, an issues log, and a corrective action report. Additional test documentation might be required by the insurance representative or maybe the AHJ, such as the local building or fire department. The integrated testing agent should be in communication with those entities throughout the process. So as Jacqueline talked about, getting that AHJ involved early about any special reporting requirements that they have up front. So some of you might already be familiar with the input-output matrix, and that's what's shown on the screen right now. Basically, the input-output matrix shows how the building will operate. So as you see on the screen, it shows the output on the top columns for every given input into the system. And the input-output matrix is something that's created by the system designer, and it's used by the integrated testing agent when they're creating their test plan. So essentially, this test plan is created to ensure that the building is operated as shown in this input-output matrix. When submitting this information, it's important to anticipate the format that it should be in. So some AHJs and building owners like it to be in the form of this chart, and some others might want it to be in the form of a narrative. So it's important to talk to them before you start creating the documentation. So as the input-output matrix is something that's created by the system designer, it's important that this input-output matrix be correct. So once the integrated testing agent is going to receive this documentation from the registered design professional, they should review it and confirm that it's correct. And then if it's not correct, they need to return it to that registered design professional in order for them to correct it for any issues. So as fire protection engineers, you may be the registered design professional for some of these integrated systems. So because of that, you need to make sure that your matrix and or your narrative include all the correct interactions with the integrated systems that are integrated with the system that you're designing. So when performing the integrated test, it's important to document how each part of the input-output matrix was tested. This can be done in the form of a sequence of operation. So the sequence of operation shows each input and then lists the subsequent outputs. And what it does is it allows the testing personnel to check whether each output is observed. So when you're documenting this procedure, it's also important to note how the input was created. So whether or not it was an actual status change. So let's use a flow switch, for example. If you flowed water, that would be the change of status for that, that flow switch. But maybe you simulated it. Maybe you manipulated the contacts of that flow switch in order to send the signal to the fire alarm. So you need to note that in the sequence of operations. And then that sequence of operations should also be noting if the testing was completed under normal power or emergency power. And then during the testing, it's likely that things will not perform as expected, and there's going to be some issues that arise. Because of that, it's important to maintain a proper issues log and a corrective action report. So the issues log outlines every time there's an issue with the tests. So let's say you were testing a smoke control system, but a few of the doors in that smoke control zone barrier didn't close. So that would be put in the issues log, and then it needs to be assigned someone to fix. Then once that issue is fixed, the person who performed the repair would then complete a corrective action report. And then this report is going to detail how the issue was resolved and then who resolved that, that issue. So just as the same as documentation, right? We're not just tracking these issues and corrective actions just to track them. A corrective action report and issues log are important to keep in order to maintain warranty of the equipment and the systems. Additionally, as you track these common issues that are occurring, you might find trends and things. So for example, if you're completing integrated testing on an office building and during the final stage of construction, there might be a change order and they have to change out the ceilings in some of these conference rooms. During your integrated testing, you find that maybe some of the notification devices aren't working correctly in some of these conference rooms. And because you have this issues log, you're able to see a trend that all of the rooms that had the ceilings replaced or all the rooms that had the issues with notification had their ceiling replaced. So maybe you're going to want to go and check the notification in all the conference rooms that had that work done. Another important thing with when performing a corrective action, you need to be careful that you're only correcting the items that were not installed per the design documents. So we'll use that example of that smoke management system, and maybe you're doing the testing, you determine that some of the smoke detectors around the perimeter of the atrium aren't programmed to actuate that smoke management system. When tested, if that desired outcome is not achieved, a recommendation could be made to include those additional detectors as part of the actuation of the smoke management system. If the original construction documents indicated that these smoke detectors should be included, then you just go ahead and create a corrective action to put those in the programming to actuate that smoke management. But if the construction documents don't include those detectors as a means to actuate that smoke management system, you're going to need to send that recommended remediation back to the original design engineer, who then will change the design documents, and then it will need to then be approved again by the authority having jurisdiction. So once the testing is completed and then the documentation is given to the owner by the integrated testing agent, it needs to be retained by the owner and or the owner's representative. and the location of documentation must be shown on the fire alarm control panel. So, and then the owner is responsible for maintaining the last 2 integrated system tests. So let's get to the part here of why NFPA 4 is so critical to understand now, and why we're talking to you guys about it now. The reason is NFPA 4 is referenced in the 2018 editions of NFPA 1, 101, 5000, and the 2018 editions of the International Building Code and the International Fire Code. So the language in 101, the Life Safety Code, and 5000, the Building Construction Code, are similar. And the language in NFPA 101 is actually extracted into NFPA 1. So in these codes, some form of integrated system testing is required for all fire protection and life safety systems. So what the code says is when a fire protection safety system is tested, the response of integrated fire protection and life safety systems shall be verified. So for example, if you're performing fire alarm testing, you need to verify that all the integrated systems are responding as intended. So if you notice in that section, it doesn't actually note NFPA 4. And the reason because that is you're not required to follow the requirements of NFPA 4. However, it can serve as a good guideline when you're doing that confirmation. But if you have a building that's a high-rise or one of the integrated systems is a smoke control system, then the integrated testing must be completed in accordance with NFPA 4. And that integrated system testing must be completed before the issuance of the certificate of occupancy. And then it goes on to note that if you have existing buildings, the integrated testing must be conducted at an interval not exceeding 10 years. And then it then allows you to specify a time greater if it's listed in your test plan, and then the AHJ also approves that. So as you can see, with the increase of smoke control systems and the construction of new high-rise buildings, you're going to start to see a lot more buildings are going to require this integrated testing per NFPA 4. That leads me to the fact that there was a lot of discussion during the revision cycle of the 2018 edition of these codes, whether or not that NFPA 4 integrated testing should be required for all occupancies. Actually, prior to what's known as a TIA, a temporary interim amendment to NFPA 101 and 5000, the language in the code actually required that integrated system testing be completed for all occupancies. It didn't just tell you that you had to do integrated testing to confirm the output. And then, but during the discussion, it was determined that they're going to start with these higher risk occupancies, such as the high rise and the smoke control systems. So that being said, I wouldn't be surprised if you see that more and more occupancies get added to this list as we go into further revision cycles. So I just want to talk real quick about the requirements that are in the building code. They're similar to the requirements in NFPA 101 and 5000, saying that you need to test the response of any integrated systems when you're doing testing. And then goes on and tells you that you need to do it per NFPA 4 if you have a high-rise building or a building with a smoke control system. So there's a lot of, as you can see, there's going to be a need for that integrated testing on projects coming from jurisdictions that adopt any of these codes. So what does this mean for you guys as a fire protection engineer? What should you guys be looking out for? It's possible that you may serve as that registered design professional for a system that could be integrated. So when you're that registered design professional, you need to prepare for that extra work that might be involved in the design phase to ensure that the systems are designed and to be integrated. And then you also need to make sure that you cover yourself for any additional time required for integrated system testing. The reason because that is on bigger projects, registered design professionals might actually be brought onto the integrated testing team to help assist with the testing. So because of that, you want to try to avoid terms in contracts such as includes all required testing. The reason because of that is that those terms are going to put you on the line to cover the cost and time needed for integrated system testing. So it's recommended to actually just include a line that an additional cost for that integrated system testing. That way it's going to start a conversation with the building owner and the design team early on before you even get brought onto the team, and they're going to determine whether or not they are going to need to be doing integrated system testing. And then the final thing is that you're going to see that jurisdictions are going to begin to adopt this 2018 edition, and then owners are going to be required to complete integrated system testing on their projects. And they're going to be looking for someone to perform that integrated system testing for them. So as a fire protection engineer, with experience and knowledge of the design, installation, operation, and maintenance of these integrated fire protection and life safety systems, this is a job that you can actually perform for these owners, and you can serve as that integrated testing agent. So this is going to be able to bring additional work for a fire protection engineer if you're willing to take advantage of these different opportunities.
All right, and we're going to be wrapping up here shortly, but everything Shawn said is very important because, you know, a lot of times you can go and listen in on these different webinars, but it's I mean, all of us being fire protection engineers or engineers are asking, okay, how does this impact me? How does this impact my life as a fire protection engineer? And, you know, as Shawn mentioned, you know, there's going to be work that is coming in the pipeline where you could be the integrated testing agent. We're already aware of some of the consulting groups that act as integrated testing agents for some of the projects that Shawn and I get to observe, and it is pretty neat. So just be aware of what NFPA 4 is, what it involves, and the good news is that we're currently in the annual 2020 revision cycle. So what does that mean? Well, it means that the public comment period, which is an opportunity for anyone from the public to submit a comment, will be open from February 22nd, 2019 through May 8th, 2019. So if there's something in there that that you don't like, now is your time, or I shouldn't say right now, but in February you'll have the opportunity to go online and submit public comment on something that that you may not be happy with or that you might want to change. So please get involved because this is coming down the pipeline. Some of the conversations that took place at the first draft meeting, just to give you an idea of what some of the discussions were, included clarifying the intent of the requirement for end-to-end integrated system testing. Again, we're not going to go through Chapter 3 definitions, but that was one of the conversations that took place. Another discussion that the committee was looking at is to remove passive fire and life safety components from being included in NFPA 4 because these components are already inspected and tested during the installation process. So those were the two, I would say, bigger technical discussions that took place at the first draft meeting in September, and we'll be meeting again, I believe, sometime next fall. The date is to be determined, but get involved and please submit public comments between February 22nd and May 8th.
All right, so let's just get on to the last thing here is that for NFPA 4, NFPA actually offers a significant amount of resources for this, and specifically for fire protection engineers. The first thing I want to talk about is actually our handbooks that include expert commentary on all of the requirements. So take a look at those. It's a good way to learn a little bit more about the intent of specific requirements, provide some examples of some specific projects or scenarios that are completed. And then also, as Jacqueline kind of noted, we're both instructors for a one-day integrated system testing fundamental class. What this actually is it's an activities-based class that we use to demonstrate the correct application of NFPA 4 on a various scale of projects. We've taught this class with AHJs, installers, contractors, engineers, and what actually happens is we get facilitate a really good discussion between everybody involved on the team. And it's a really good way to get a new perspective on how things are completed for integrated systems. We're going to be offering that class next year in Rosemont, Illinois, and then also in Tarrytown, New York. So if you want to learn more about that, you can go to nfpa.org/4classroom. And we also offer a free tutorial on integrated system testing and other resources such as fact sheets. That's all available at nfpa.org/4. So that's all we have as far as the presentation. I think we're ready to take some questions from you guys if you have any.
Thanks, Shawn and Jacqueline. Yeah, we do have some time to take some questions, so let's get started. I've had some questions coming in, and we'll try to get through as many as we can before the end of the hour. If you guys have a few minutes to extend and get through a few more, just let me know. Otherwise, we'll just send you the emails, and hopefully you can get to them offline. So the first question we have here is, should cybersecurity be considered in integrated testing?
Yeah, it's a good question. So the one thing that I wanted to get to, or that I think Jacqueline talked about too, is the fact that NFPA 4 is not really prescriptive. So it's not going to go list all the specific systems that you need to be testing in your integrated test plan. And the reason because of that is they understand that technology is going to be constantly advancing, and you're never going to be able to keep on top of all the different types of systems that are integrated. So that being said, that's sort of a discussion that you're going to need to have with the building owner, the AHJ, maybe even the insurance reps, to determine if that cyber threat is something that's going to threaten the building or maybe even your business. So that is up to the integrated test team to sort of sit down and figure out what are the risks involved. Is this something that we need to be testing in the integrated plan?
Great, thanks. The next question we have is, can we assume that there are no specific qualification requirements regarding who performs or oversees the integrated testing of fire protection systems? Can any professional engineer or architect perform these roles?
Okay, I'll take this one. So NFPA 4, we provide a list of qualifications for the integrated testing agent, but as I mentioned, there's no certification or licensure, and that's what makes it difficult to really find how do you know what a good integrated testing agent is when this is a new concept, a new thing, since NFPA 4 has only been out there for a couple of years. And that's why we stress the importance of someone who is excellent with their communication skills. That includes both speaking and listening, as well as someone who knows the systems in your building inside and out. So, you know, it might be, if you do commissioning in your building, you could have the fire commissioning agent act as the integrated testing agent, because that might be someone who knows your systems inside and out. But just because you had, you know, one person do one building doesn't necessarily mean they're going to be the great or the best integrated testing agent for you on the next building, because it's we really emphasize the importance in knowing the systems within your building or within your facility. So it's more important for the integrated testing agent to know the systems that you have specific to your building, then that's more important than anything else. So I would say that you really want someone who, in addition to knowing the systems, knows the performance verification methods between those systems, because as they're developing the test plan and the test scenarios, they really need to know how that input-output matrix should work. So again, I would put the bread and butter on someone who knows the systems inside and out for your specific building.
Great, thanks. The next question we have is, should integration testing include systems that are outside of the fire life safety systems? For example, lighting control panels integration so that egress lights can be brought online during an alarm event.
Yeah, so again, this is one of those things where that sort of question is going to get answered when you have that first meeting with the team. Essentially, when you have the building owner sit down, any other stakeholders that are involved, and you sort of talk about, well, what are the risks to the building? So the biggest thing that the building codes, so 101, 5000, and the IBC, they're looking at life safety systems and fire protection systems. So that's the biggest requirement. So anything that's going to affect fire protection and life safety is going to need to be tested. So that meaning if you have a generator that is supplying power to everything under emergency power, and maybe that generator is supplying power to some other systems that aren't necessarily life safety, you need to include those to make sure that they're not adversely affecting all of the life safety systems. But then if the building owner decides that there's other things that they want to make sure is working correctly and integrated, such as lighting control and security, security that doesn't necessarily affect egress, then those are things that can be added. But again, that's going to increase the costs. So that's something that the owner is going to want to decide on.
Okay, Great. Well, we actually have quite a few number of questions left, so instead of trying to squeeze this in before we stop the hour, we'll collect these, send these to you guys, and then hopefully you can get to them in offline and respond to these individuals. So before we wrap up the seminar, do you want to make 2 announcements? One, SFP is bringing 2 courses to the Chicago area this December 5th and 6th, with 1-day fire and life safety design of very tall buildings, challenges and solutions, with the instructor, Carl Baldessara, who is SFP past president. And then we have a 1-day seminar on performance-based design and the codes with instructor Chris Jelenowitz, SFP technical director. These will be held in the Northbrook area of the Chicago suburbs. For more information, please check out www.sfp.com and look for our upcoming events. Our next SFP webinar will be Monday, November 26th at 11 a.m. We'll be discussing changing the face of the fire problem. So thanks to everyone who participated in today's webinar, and thanks again to Jacqueline and Shawn for an outstanding presentation.
Thank you for having us.
Yes, thank you.
Have a good day, everyone.